Hello, good afternoon, sir.
Good afternoon.
Can we
Good afternoon.
introduce you? Are you ready?
Yeah, please go ahead. Sure.
Yeah, let me read your profile. Good afternoon, Mr. Manikant, sir, from AML Lead, Steward Company, Mumbai. Manikant, sir, is a data science and generative AI experienced professional with over 11 years across product and service-based companies. A passionate teacher and mentor and loves to create AI-powered products to solve complex problems. He believes in sharing knowledge and creating a positive impact through AI products. We welcome you, sir. You can start your session.
Okay. Thank you. Thank you very much for the warm welcome. And firstly, let me say that thanks for this opportunity for all of the esteemed faculty members at Anurag University and other universities wherever you guys are joining from. It's truly a wonderful opportunity for me to actually engage with all of you guys. It's really inspiring for me also from my side. Now, let me start by sharing the screen. 1 second. Yeah. Okay. So I am going to talk about this one particular use case in Gen AI right now, which is quite much trending right now, which is very much in the market demand right now, which is to develop private chatbots for a lot of enterprises, a lot of individuals. So it is similar to ChatGPT, Gemini, Bart, and all of this, but having something on their private enterprise level. So that companies can actually use their own private data and start chatting with that private data. Obviously, all of the companies' data won't be available publicly. Therefore, these ChatGPT, Gemini, they are not trained on this private data of companies because they are not available in public, right? And the companies do not want to release this data in the public because of a lot of security and other measures and so on. So my entire today's major point of discussion is going to be about how to develop such a chatbot. And before this, I will be going through these important 4 aspects. So the agenda for today's sessions will be on a very high level. Roughly, this is what I'm going to discuss. First is I will try to give you a very high level understanding of what is Gen AI. I'm pretty sure most of you guys might already know this, but still, it's just a good start to begin with. I just want to start with gear 1 and then go to gear 2, 3, and 5, 6, and so on. So I'll start with gear 1 here. What is Gen AI? What are the different industry demands right now? What are the different use cases right now in Gen AI and different solutions that are possible, right? Followed by that, one kind of a solution, which is RAG, which will be used to actually implement a private Gen AI chatbot using RAG. That is exactly what this session mostly complete is going to be about. Third is I will go through the RAG concept. Second is I will explain the RAG concept. Third is I will go through the code walkthrough and also demonstration of how the entire chatbot works. So we will take an LLM model from Hugging Face, we'll download it, and we will use that LLM model and we will give our own data set from internet. We'll give some data set and we'll ask questions on that data set. We will see how RAG architecture would actually work on this particular code code pipeline. And followed by that, definitely I would like to keep around 15-20 minutes. Most of the time I want to keep open for questions because I am really interested to looking forward to different kinds of interesting questions from all of you guys, right? So before I begin, let me attempt to start with a joke, right? So I just want to ask a question to everyone, and I don't know how the communication works here. So can anybody unmute and speak, or is it via chat box that people should actually communicate in this? Can anyone confirm? So I just want to ask one simple question. Why does AI never get sunburnt?
It's via chat box only.
Through the chat box only, okay?
Yeah.
Okay, that's great. AI never gets sunburnt, right? So why is the question? Why do you think? And please don't go and think all logically about this. It's a silly joke. So try to be a little bit of creative in this. Why doesn't an AI never get sunburned? We humans, when we go to a beach or whatever, we definitely, and especially in this climate, extreme hot, at least from where I am joining from Hyderabad, it's too hot right now. So it's quite common to get tan, sunburn, and all of this. Let me see if there are any. Yeah, anybody can try to answer this in chat box, or at least try to think about it. I'll just wait for a few seconds and then I will give the answer. Again, it's nothing logical about it. It's just a simple silly joke. Okay. It's a software. Okay, that is actually correct. I would agree. It's a software, so there is no chance it will get sunburn. That's logically correct. Anyone else wants to give a try? People are using source scope to tan funny. Okay, okay. So the answer to this is because AI is always under cloud. Okay, either it is under Azure cloud or AWS cloud or whatever it is. It's always under cloud, so there is no chance it will get sunburned. But again, like I said, there is nothing logical in it. It's just a simple silly joke. I just wanted to start with it because it is post lunch and people might be little uh, drowsy after all the food. Okay, so anyway, so let me begin, guys. Now I will start with what is Gen AI. So throughout this entire 1 hour approximately, I will be going through the slides. I will actually use some notes to actually give some examples. I'll go back to notes. I will write something and give some examples, and I will go to code. I will demonstrate the code. I will show the output, and also use ChatGPT sometimes. ChatGPT, Gemini, I'll use sometimes to actually demonstrate and explain something. So I'll be just moving around from one resource to other resource so that we understand things, very easy manner, right? So now first understand what is this generative AI, what is a generative AI, and what are the various use cases that are available in the market right now, right? So AI tools, there are a lot of AI tools like ChatGPT. We also have Sora, which actually takes text as input and create videos, right? All of these are AI tools, right? And all of these tools are called generative AI tools, right? So now, if I give a very bookish definition of generative AI, let me minimize this. A bookish definition of generative AI, this is what it is, right? So it's a type of AI, generative AI is a type of AI that can create, second, yeah, that can create content, can create new content like images, text, audio, video, music, and so on, right? And it is actually powered by foundation models. All these models, GPT-3, 3.5, 4, these are called foundation models, right? And we'll see more about what are these foundation models. So these foundation models are trained on lots of data set, lots of internet data from Wikipedia, lots of books, and GitHub code. They have seen entire data available in the internet, and they have been trained in a model where they have to predict the next word. So they will look at all the words and they have to predict the next word. And a lot of models are trained like this. We also have Llama 2, which is by Meta. There are a lot of models, and these are foundational models. We take these foundational models, and top of that, we again do some kind of task, some kind of little bit of software engineering and AI part to be able to accomplish bigger tasks like classification, image generation, question and answer, summarization, and so on. Okay, and all of these generative AI models are essentially deep learning models by nature. The very beginning is that we take either LSTM models, GRU models, which are all time series based neural network models, but they have many hidden layers, so they are called as deep learning models. We take all of these deep learning models, we apply transformers mechanism from this famous papers called famous research paper called Attention is All You Need. We apply the transformers mechanism and attention mechanism and get the context understanding much better. Context of words, context of images, context of videos, whatever, we understand it much better when we apply these transformers on top of deep learning. And we have complex architectures. It's not just one deep learning model we have. We would have hundreds of deep learning models connected in a very complex manner in a complex architecture. We have encoder, decoder only, encoder only. Different types of architectures are there, right? So all these foundation Gen AI models, foundation Gen AI models are nothing but a complex architecture made up of multiple deep learning models internally, right? And they are connected in a very complex manner based on the task. And each of these deep learning model have attention mechanism incorporated before itself, right? And finally, through the learning process, what happens is these generative models will develop a representation of the training data, representation using lots of probability distributions, and this will be useful in many cases. For example, if you write something, let's say, please find attachment of my resume, okay, and then you will write looking forward, right? If you write this, you will observe that in Gmail, automatically these words you will get some suggestions, like looking forward for your reply. Something like this, Gmail would actually give you the suggestion, right? Why are you getting these words as suggestion is because there has been a probability distribution that already pre-computed during the training process, and it is seeing that if these are the words initially, then these are the words, last two words, most likely, most probable, given these are the words initially. And that has been derived from this probability distribution, right? Which got constructed using the training process from these deep learning models, Gen AI models essentially on a very large scale. So Gen AI models are nothing but a very scaled up version of deep learning models. And this last point is extremely important. What I want to highlight over here is that traditional AI usually deals with numerical data and some amount of text data. Generative AI, on the other hand, deals with creating content on its own, So what I mean by this, if I show you this example, generative AI versus predictive AI. If you look at examples of predictive AI, so both are doing predictions. Definitely, generative AI is also predicting what could be the answer given a question. Predictive AI also will predict, but the difference is in terms of what is in the output. In the predictive AI or simple machine learning models, let's say linear regression or decision tree for classification task and whatever, usually we'll have things like this, where we predict the Microsoft stock price tomorrow, what it will be. Okay, that's one example. This is an example of machine learning, simple machine learning task, or forecasting time series task, or predictive AI. Okay, and then given a particular transaction, credit card transaction, you can tell if it's a fraud or not a fraud. And then given the customer details, what is this guy's uh, years of experience, credit score, and so on, the model can tell how much loan to give, right? So all these, as you can see, are point level prediction. Point level. It is giving you prediction as yes or no, or 20 lakhs, $325. It's a point prediction. It's not a big sentence. It's not a big image that is being predicted, right? Now, this is, let me erase this. Yeah, this is an example of simple predictive AI, right? Or simple machine learning task where we predict tomorrow what will be the stock price. Tomorrow, what will be the stock price? Using lots of models, right? You can use XGBoost, you can use and you can use time series forecasting models like ARIMA. Many things can be used. But generative AI, on the other hand, use cases examples. What are some examples of use cases are for generative AI? I think a lot of you guys can guess, definitely. Writing stories, writing script, generating an image, generating a video, generating code, creating chatbots which can actually answer the questions, having co-pilots, Microsoft Copilot, which will actually look at what is there in the Excel sheet and then generate the graphs for you. It can look at what is there in the email and generate auto email, auto reply for you. So it is all what generating a big thing. For example, I gave a question, write an email requesting for 2 days leave for my housewarming ceremony, make it in 8 to 10 lines I've given. So I got the reply. It has generated the text. It is not a point level. It's not a point level prediction. It is generating a huge email. It is generating a huge image or a script or a story or entire code. So this is why it is called as generative AI. That is why it's called as generative AI, because it is synthetically generating, artificially generating a lot of things through the probability distributions from these LLMs that it has learned during the training process. And during the training process, it has seen all of the internet data, almost all of the internet data. Yeah, why it is named as predictive is because that is to differentiate. Whenever there is a prediction involved, what is AI? AI simply stands for artificial intelligence, right? Artificially intelligent. We are making a machine artificially intelligent, and it is becoming intelligent by by looking at the past data. By looking at the past data, it will look at the past data and understand the patterns. It will capture the patterns, and using the patterns, it will predict the future, right? As much accurately as possible, it will predict the future. That is the entire purpose of AI, right? Artificially intelligent. It is becoming intelligent by learning from the past data. Okay, but past data can be anything. Let us say past data belongs to stock price of Microsoft. So this AI, which internally has a model, let us say RNN model it uses to actually look at the past data and identify pattern, and then using that, it is predicting that, okay, tomorrow stock price of Microsoft will be $325. So it is only a prediction for Microsoft, that is only for tomorrow, and only for tomorrow closing price or average price, nothing else. So it's only a discriminative level or point level prediction, right? But there can be many kinds of prediction. People can predict what could be if I have given a half story and I ask, please complete the story for me, then ChatGPT can predict what could be the remaining half of the story and fill that for me. It's a huge prediction, right? It is generating something. It is generating more words. It's not one thing, right? It is generating from the probability distribution that it has learned, right? Probability distribution. Only when there are probabilities that has been learned, probability distribution that has been learned under a particular constraints, only through the probability distribution anything can be generated, right? So all these models which have probability distribution in the back end, those models will be able to generate a new story, generate a new image, right? But models like decision tree, which do not have any probability distribution internally, linear regression, they are not generative models. They are simply discriminative models, logistic regression. All right, discriminative. What do they discriminate? They discriminate whether to give loan or not to give loan, right? They discriminate whether the person has cancer or the person do not have cancer. That's a simple example of model. This is also prediction, right? But it is of a smaller level prediction. These are higher level predictions, more complex. So everything comes under AI. Yeah, basically classify, and also regression task also will come under that. Right. So now let us see. So I have highlighted the most popular and trending Gen AI use cases in the market right now. I have got an exhaustive list, but this is not the only list, guys. There are many other use cases, but this is just to begin with, right? I'm just starting with. Can you guys tell any Gen AI use case? Anything that you can tell in the chat box? Any generative AI use case that you have, personally have used, and you have used Gen AI somewhere in your work or somewhere in your, let's say, personal life. Yes, you have used ChatGPT, but for what? Is it for Is it for actually writing some document? Is it for, let's say, writing code? What did you use it for? For research writing. Okay, so that is one use case. Okay, good. And some people might have used, okay, a lot of people, because all of you guys are PhD, grads and complete into research. So it makes sense. Everybody are into research and trying to use ChatGPT for it. Yes, these are some examples, right? So the first example, very straightforward example, is for content creation. A lot of people use ChatGPT like tools, which are Gen AI tools, right? ChatGPT, Bart, and so on for content creation. I regularly post in LinkedIn. At least I try to. So I get a lot of content from ChatGPT. I'll just give a prompt like, please compose a post about RAG in 10 lines and make sure it is understandable even by a 5-year-old. Something like that I'll give, and I'll get the output from ChatGPT. I will edit it myself to add my own personal touch and style, and then I'll publish it in LinkedIn. A lot of people do it for other kinds of content creation also. People do it for image creation, animations, and videos, so all of these. So images, superhero images, templates, scenery, videos, advertisements, movie clips. Nowadays, movies are also using a lot Gen AI. Templates, blogs, to write blogs, articles. All this comes under content generation. Content generation. Next is code generation. People can generate code also. Some examples are code creation, code completion. Already some code I have written. I will copy paste that code in ChatGPT, and I will tell I want the array to be reversed. I have written half of the code. Can you finish the rest of the code for me? So it will take it and it will finish the rest of the code. Code review. code review. So I can copy paste the code I have written in ChatGPT and ask it to review and tell me, is it following solid principles? In coding, usually we follow solid principles, right? Is it following all of the basic OOPS principles? Is there anything that can be eliminated or minimized and make the code design even more better? That is something I can do. Test cases also I can generate. So I have written software code, software logic I have written, which is from my. So I have been given with certain requirements. I have written the code for it. I need to test the code, right? It might fail in the edge cases. So I will tell what is the requirement. I will give the code. Sorry, I will tell what is the requirement and I will tell generate test cases based on the requirement. So ChatGPT can give you test cases, which I can automatically copy paste it and then test my particular code, how it is working. Otherwise, I would have to manually create the test cases. If I don't have testing team support, usually when we create, we all software developers have to do testing, some level of testing on their own also. So at least that can be, made a little bit faster using these tools, right? So all of these things, the code generation doesn't mean only getting the code. Test cases, code review, code completion, many things will come. Creating private chatbots like ChatGPT for your own internal, right? So for example, let us say, hmm, let me take somebody. So I can see Dr. M. Trupti and I can see Raghavendra. So let's say you guys want to create your own website, okay? And you have your own website, which tells about your profile, what PhD you have done, what is your research about, your research paper link, and at the bottom there is a chatbot. There's a chatbot. So anybody who visits your website can actually ask your chatbot. Let's say I am visiting your website. So I can ask, hey, how many years of experience he has? What is his research area? What is his research area? Can you show me the research paper link? Which university did he do research? I can ask all these questions to this chatbot and it will give me the answer, right? Instead of me going through each and everything. So you don't want to put it. So it's like you're having your own personal digital version, right? Or digital version, I wouldn't say personal, info chatbot, right? Right. Let's say some recruiter wants to get to know about you. So you're not available in the call. So the recruiter can actually go to your website, chat with the chatbot. Yeah, the recruiter can ask, are you open for any location? And then, no, I'm open only for Hyderabad. So the recruiter will decide, okay, it's for Bangalore, so let's not proceed forward. So, things can that like happen. So you can have your own private chatbot, right? All these can happen. So I'll just go a little quick, guys, because I'm pretty sure all of these might be quite uh, obvious for you. So the next is product development we can use. I can create prototypes using Gen AI. I can create feedback loop mechanism, virtual assistant, conversation analysis. Let's say there is a email conversation going on between your boss and you, or a 10 to 15 email chain is there. So I can have a conversation analysis, summary of a certain textbook, summary of a research paper, summary of a lot of LinkedIn articles. Many things can be taken. Virtual try-on. So let's say Lenskart is one example. Lenskart has virtual try-on of goggles, right? You can select your goggles and you can have virtual try-on. You just have to click your image and your image will be here and you will have a virtual try-on. So this is becoming quite common. It's obviously this generated, artificially generated. Your image digital version is generated with this glasses. Synthetic data generation, generating more data for different use cases. Okay. And let's say you go to financial sector or insurance sector, there will be a lot of invoices that will be generated on day-to-day manner, right? Usually invoices are generated by these human, who are in a particular division. They will actually type everything or they will actually copy paste a template and do it. But if you can ask AI to generate a particular template for so and so use case, generate an invoice template for so and so use case, it will generate it quickly for you. It'll generate a template for you, right? It will generate a template invoice for you, where in that invoice you may have your company name, your stamp, your name, your date, and so on. AI enabled BPO contact center, BPOs, but let's say the people who actually support system, help system, that can be automated with AI to a decent extent. Drug discovery, medical report analysis, gamification. Since you guys are in education sector, all of you are PhD graduates, in education sector, you can actually develop courses that are personalized learning. The courses can be personalized learning. That is, you'll have a roadmap designed as per the individual student, right? And you can have a gamified version because you can have a reward, you can have a punishment mechanism that will actually keep the student engaged and then generate more content. So let's say the student failed to understand about the concept about topic number one, topic number two, let's say, which is where the video is about something. So what can happen is from the video, I can generate a PPT or slides, whatever I explain in the video, I can generate slides and then give that to this particular student to revise, right? So many things can be done. Gamification can be done. So all of these things can be done. So it might look like what we do after AI takes over. So we have to see digital twin AI, avatar, movies, all these are examples of it development. Yes. So now comes the interesting part, guys. So the answer to all of these use cases, to implement all of these use cases on a major level, there are only four kind of solutions. On a major level, high level, that too in the industry right now, only four solutions are happening. One is prompt engineering. Prompt engineering is a solution. Second is RAG. RAG. Third is fine-tuning of model. Fourth is creating a model from scratch, model training from scratch. And this is as per the increasing order of the difficulty, guys. As per the increasing order of difficulty. This is most easy. I'm not telling prompt engineering is easy. Actually, it is easy, but compared to others, it is much easier. This is easy. This is okay. This is medium. This is very hard to actually implement. When I say hard in terms of time, okay, in terms of time and in terms of money, this is very hard. This is medium. This is okay and this is okay. Not money is required. Not much money is required for prompt engineering, and it is also not much time taking. RAG is decent. Fine tuning is still a lot of companies don't prefer fine tuning because of many reasons, which we will see. And this is hard. Finally, model pre-training is hard. You can also see the effort required here. Low, below average, average, or low, average, above average, very high. Effort required, full. Similarly, cost you can see, right? So this is how the things are. So now let us understand all of these solutions. Prompt engineering, we will understand first, followed by we will look little bit about each of these and we will see why to go for RAG and when to go for RAG. And we will understand what is the concept of RAG. Okay. So let's have a small demo about prompt engineering. Let me show you something, guys. 1 second. Yeah. Okay. So now let me say I will ask ChatGPT a question. Tell me about stars. So this is what I asked ChatGPT. So if you see the response, it is giving me formation of stars, vast cloud of gases, dust, nebula, gravitational force. Yes, it's all correct, definitely correct. Life cycle, energy production, luminosity. Okay, for me, uh, a lot of things are going out of my head, right? Because I don't know. I'm not a technical guy with respect to astrophysics or all of this. But yes, it's fine. But actually, what I wanted was, I wanted to I wanted to have some facts about stars, some some creative thing about stars I wanted to know. So uh, this kind of prompt is not actually giving me the answer what I want. So let me change the prompt a little bit, see what I will try to do. Tell me about stars. About stars, okay. And then I will tell you are a poet. You are a poet. Okay, now let me see what would be the response like. So the response is in terms of creative side, it's not talking much about the technical aspects, how the galaxy, how the stars are formed, the life cycle, all that is not there, but there is darkness, thrive, skies, beacon of light, more of a positive, optimistic hope. That's exactly what I wanted. I actually came to ChatGPT in the intention of, let's say, feeling hopeful and feeling creative, right? Feeling positive, and so on. That's why I wanted to, know some things about stars. but the kind of prompt I've given is not accurate, right? It is exactly like how we communicate with our friends or how we communicate with our students or faculty members. If I want something, I should exactly tell what it is. That if I tell, hey, go get me an apple, well, it could be that I'm talking about the Apple MacBook or I'm talking about Apple fruit, depends upon context, of course. But the point is we have to tell clearly what we want, right? And that is all prompt engineering is all about. That's all prompt engineering is all about. Now, let me show you one more example. So let's say, yeah, create a LinkedIn article on how AI is used in manufacturing history. Now I will also tell, make it within 100 words. So as you can see, I'm getting some information. So this is good enough, right? If I want, I can take it, I can edit it a little bit, I can modify it, and I can actually go, do it. Now we know that in ChatGPT 4, which is an advanced version, I also have DALI model included, which can give me the images also. I can also ask to include suitable images. Okay, suitable images. So it will include images after this particular text, right? So this is an example of prompt engineering. And one more thing, if you have observed, I have specifically asked it to put it under 100 words. The reason is because I know LinkedIn has restriction of words, right? It has restriction of, I don't know, 500 or 600 words. I think 1,000 words, if I don't know exactly, but it has a restriction. So I don't want it to go beyond 1,000 words or 100 words. That's why I made it a restriction. So I have given this. That is why I got the output in this manner, right? So I have to specifically tell everything. Okay. So now if I ask you for, yeah, there are a lot of use cases in medical industry, lots of use cases. So now if I ask you, I will give you a use case where actually you have to create you have to actually create a blog. Already website is there. You have a website, you have a blog and everything. Every day you have to post a blog about AI in every industry. First day you have to post AI in manufacturing industry. Second day you have to post AI in finance industry. Third in AI in medical industry. Like that, 10 industries you have to take. And every day you have to post one article about how AI will impact in each of the industry. You have to generate images also, right? So for this use case, is prompt engineering good enough or not? Or do you need to actually train your own model? Do you have to actually train your own model? Or can you use existing model like ChatGPT, GPT, or Gemini? Is it good enough? All you have to do is ask the question appropriately to get the answer appropriately. What do you guys think? Anyone in the chat box? So as you can see here, I have clearly asked the existing model behind this ChatGPT is GPT 3.5 model, right? I only asked the question and I got the answer. Why did I get the answer? Because this model has already been trained on a lot of data, AI, manufacturing industry. It has seen a lot of Wikipedia data, it has seen a lot of blogs, it has seen a lot of books. Therefore, it is able to answer this, right? But if I ask anything, if I ask, let's say, let me take one of the audience, I can see Sujata. Okay. So I will ask a question. Please tell me what is the research area of Sujata. I'm not taking your last name because I don't want OpenAI and all of these things to have this name. So let's see. So I will ask, please tell me what is the research area of Sujata. So will ChatGPT able to answer this question to me? Will it be able to answer this question to me? Yes, it cannot answer. It cannot answer because this is not trained on any of it. Yeah, I have no enough context to tell. So that's what it's telling. Right. So in this case, do I need to train my model on information about Sujata? First, I need to gather information about Sujata, that what is her background, her PhD, her university, where is he working, everything I have to gather, and then I will have to give it in a particular format to train the model. That on that new model, which has learned the information about Sujata over here, on that model, if I ask question, it will answer. It will give me the answer. Fine. Now, in this case, prompt engineering did not work. Prompt engineering, because there is no information about, when information is available to the model, I can give any prompt to get the answer. Now there is no information. Prompt engineering won't work in this case. I need to do either fine tuning or RAG. We will see what that is. We will see what that is. But first, we need to understand fine tuning. Pre-training is not, sorry, prompt engineering is not possible for this, right? Now, if I want to write an article about AI in healthcare industry, do I have to take an Chat GPT 3.5 model and then train it on a particular book called AI in healthcare, and then start asking the prompts? Or can I directly ask the prompt in this over here? I can directly ask the prompt here, right? Because this Chat GPT has already seen all of this. It got trained on all of this data. Okay. It got trained on all of this data, so I can get it. Right. So the major distinguish between when to use prompt engineering and when to use fine tuning or RAG is, if model already knows the information, then you just ask the question, ask the prompt, but ask it in a particular good way so that you get the answer what you want. Don't ask anything. Don't ask like a person who communicates very badly. Even human can't understand that way. So it should be clear what you want. Okay, so that is one thing. Now let's proceed to the next part. So now we know that this won't work in many cases. So let's say I want to build a chatbot for your company data. So let's say you're going to a company, or you're working for you're in your university, and for your university or for your company, you want to build a chatbot, which you will deploy in the website of the university or website of your company, right? What will that chatbot do? It will answer any question about the university, right? About the faculty members. It will answer any question about the company, number of employees in the company, when was the company founded, what is the mission of the company, everything it will answer. For that, first you need to gather that information and take a model, and then you will have to fine tune it. This is the first process, guys. See, there will be a large language model, and initially all of the internet data has been given to this LLM, right? Like this, many are there: GPT 3.5, Llama 2, okay, Mixtral, Grok, many models are there. Okay, now you can take any of this model. Let us say I will take GPT 3.5. I will take this model. This model already has the data of the entire internet data it has, and lots of books and many things, everything it has. What is available in public it has. What are in public it has. Now, to this GPT, you will give your data about your company. You will give. Okay, and lots of examples of question answer you'll give. When was the company founded? 2005. What is the mission of the company? We want to become number one in AI. We want to create robots and sell to every house. Like this, there will be many things. Okay, this you have shown it to this GPT. This you have shown it to GPT 3.5, which we call it as fine tuning. Okay, this model building initial when the GPT 3.5 was built by whom? OpenAI. Has built this model, and that process is called as pre-training. This is called pre-training process, where everything is learning from scratch. You have taken a pre-trained model called GPT, and you are training on your local machine or on your cloud environment with your own company data. That is called fine-tuning, which means on top of the internet data, your company data it has learned. On top of the internet data, your company data it has learned. Now you can call it as GPT 3.5 underscore Deloitte, let us say. Assume you are working for Deloitte. So you have developed a GPT version for Deloitte. Okay. Or any other thing. Let's say you have your own startup. Let me take this only. Deloitte. Okay. So you have developed it, which this model will be available only within Deloitte company. It should not be available in public. If it is available in public, then anybody can ask questions about Deloitte. What is the revenue? What is the secret of Deloitte? What is the strategy of Deloitte? Everybody can ask. That should not be there. It will be safely, securely available in your system, in the Deloitte system. Okay, infrastructure system. This is called as fine tuning. But the problem with fine tuning is you have to create data. You have to create data like this. You have to create data like this. Okay. Lots of examples have to be created. All right. And it is expensive process. It is time taking process. It is expensive because model training would happen in some cloud environment, Azure or AWS or whatever, and there is a charge for everything. And there's charge for everything. That is why people do not prefer fine tuning also. They prefer RAG. They prefer RAG approach. This is little less expensive, little less time taken to implement, okay, and less complex to implement. Less complex to implement. Now we will now we will understand this RAG approach. Okay, now this is where the main heart of the entire today's discussion we are going to have. Yeah. So to create the private chatbot using RAG approach, you can create using fine tuning, but that is a very, very time taking process. So this can be useful in many places. Let us say you have a bunch of auditors who actually go through all of these documents, heavy, heavy documents they go through every day. They are always exhausted. They're always exhausted and they're always, mm, co- confused, they are always in search of information. And usually auditors, financial advisors, business analysts, they actually go through all of these documents in a day-to-day manner. So if this can be digitally, these documents can be digitally created and then available in a particular cloud environment, which the GenAI model can actually see this and then answer questions, it will be very useful for them. It will be very useful for them. So the objective is to take these team members. It's not to eliminate these team members. It's not to eliminate auditors or eliminate business analysts. It is for them to actually start using Gen AI and then do, for example, if the boss asks, can you tell me, please read these 10 documents and can you tell me your final decision? So he might take 2 days time and then he will give the final decision whether to uh, put investment or not. Right? That usually it will take 2-3 days time for experts to analyze everything and give the decision. But with the help of Gen AI, where the documents are uploaded in the cloud, and then you will ask questions: what is the revenue of this company? How is it performing? Who are the investors? What is the market share? Everything you will ask, and you will get the answer from the chatbot. Instead of this guy manually going through every page one by one, every line one by one, you will get the answer from chatbot. So what could have taken 2 days could have been solved in 5 hours or 6 hours. The final decision can be made. So our objective is to have a chatbot like this, a UI chatbot like this, where the auditors can actually upload any document. They can select any document and upload it, select any document and upload it, and start asking questions, right? And like I said, to implement such a chatbot, there are two ways: fine tuning and RAG. Fine tuning we have already discussed. It's costly, requires infrastructure. It doesn't work on dynamic data. When new data comes, again you have to fine tune. It is good. Oh, it is actually better. A lot of people say fine tuning is better than RAG, but it's still debatable. Okay. So context understanding is given, accuracy, performance, everything will be good. So this is how fine tuning process will look like. RAG, on the other hand, the model will not learn anything. So we will take the GPT 3.5, GPT 3.5, okay, and we will have the data of company data, okay, company data, okay, right? In this case, what is happening here again, company data is there, which will be shown to this GPT 3.5. Now GPT 3.5 has learned the internet data. Now it has also learned the company data, which means the fine tuning has happened. In this case, GPT 3.5 knows only internet data. It has still not learned the company data, it's still not learned. But still, it will be able to answer any questions related to the company. It'll still be able to answer. Okay. We will see that how. We will understand that how. So the first advantage is because I'm not training my model. Model training on my data is not happening. So the training cost is gone. The training cost is gone. Right? Training time is gone. But still, it can answer any question from the company data, which is available in the document. Not any question, most of the questions, right? It can identify context, it will use the reasoning power of this LLM and so on, right? It's easy to modify architecture, reasoning is good. Hallucinations are downside. These are downsides. There are different types of data it can't handle, but there are many alternatives now. Reasoning is better. So this is how it is. So like as you can see, I will take a base LLM like GPT 3.5, and I will give the information about my company. Pre-training will happen. So pre-training has happened. Therefore, I have my local company level LLM ready. I can ask any question. On the other hand, I have here LLM GPT 3.5. Okay, and I have my data. User will ask a question, and that question relevant answer where it can be available will be identified first. Relevant documents will be identified. Right. For example, somebody asks, when was the company founded? Company was founded in 2005. To answer this question, nobody has to read through all the 100 books, right? Maybe it is there in book number 3, in page number 1. That's where the answer is. So you just take that relevant information and then you can answer the question. Okay, you can answer the question. That is one example. So let's see one example of ChatGPT here. Sorry, I mean the RAG example I would like to show here. Yeah, let's check time. Yeah, guys. So in the interest of time, I'm going to only the important points, guys, because definitely a lot can be actually covered, but still I'm going only the important points. Now let me write Sachin and Rahul are brothers. Okay. Now I will also write Sachin is working for IT firm. Rahul is doing B.Tech. Okay, and also Rahul has Rakesh as friend. So this is some information I've given. Okay, I've given this information. Now I will ask ChatGPT this question. What is Sachin to Rahul? Right, and it's very simple, very important. The most important aspect of RAG is this, guys. If you understand this, it means you understood what we're trying to do in RAG. It's very straightforward and simple, actually. So I have given some information and I'm asking question to ChatGPT, what is Sachin to Rahul? Right? Will ChatGPT be able to answer this? Yes or no? What do you think? First of all, I will show you the output, but what do you guys think? Will ChatGPT be able to answer this or not answer this? Okay, somebody is telling yes. Okay. Yeah, so let me show. Sachin is Rahul's brother. It is able to answer. Right. So observe what happened here. ChatGPT or GPT 3.5, initially it was not trained on this data. Sachin, Rahul brothers, Rahul is doing B.Tech, Rahul friend Rakesh. That information was not part of the training data before. ChatGPT got trained. We have ChatGPT, we have GPT 3.5 model, which doesn't know any information about Sachin, Rahul, and Rakesh. But here I am giving that information to GPT. Okay. I am giving information. I'm asking GPT to look at this information and answer this question. It's okay. You don't know about Rahul, Sachin before. You are not trained before. But can you see, I am giving some information about them here. Based on information, can you answer? ChatGPT, can you answer? That's what I did, and it's able to answer because ChatGPT has this reasoning power. Reasoning power. It's not just a bunch of probabilities, and yes, it is internally that only, but because of the probabilities and because of the learning and understanding and interdependencies between the points or words in this case, it is able to have a reasoning ability. Because of the reasoning ability, it is able to figure out their brothers. Okay. Now let me ask one more question. Let me ask one more question. Okay. Now what is Rakesh? One second, guys. What is Rakesh? Let's say company name. Okay, I will ask it. Will it be able to answer? It will not be able to answer, right? I have not given any information about Rakesh's company is working. So when the information is not there, how will GPT answer? And the GPT was not trained anything on Rakesh also before. It got trained on many internet data, but Rakesh, which Rakesh, who Rakesh, nobody knows, right? But famous people it can answer. For example, if I tell what is um, the political role of Obama, it knows all the internet data, so it can answer. That is fine, right? But somebody who's Rakesh, no, ChatGPT doesn't know. But I have not given information about Rakesh also, so it can't tell. It can't tell, right? So this is one thing. So I hope you are able to understand. Now we will see how actually uh, this RAG is useful. RAG is useful. Okay, and also one more last example I would like to show guys here. So observe this. Observe this. I want to tell it has a much better reasoning ability. So here, Rahul and Prakash are siblings. Prakash works for Deloitte. Rahul is studying BTech. Rahul likes to watch action movies. Rahul and his sister Divya are great at sports. How is Rahul related to Divya? Explain. It gave me answer. Rahul and Divya are siblings since they share at least one parent in common. The evident fact they refer to as own sister and sibling for information. So Rahul is Divya's brother, which is correct answer. It's a correct answer, right? But let us say, let us say, I don't want all this explanation. Just tell me what it is. Don't explain why, and I'm not interested. So I will tell answer in one line. Answer in one line. You see, you got the answer in one line, right? So here, what did I do? I gave a prompt in a particular way with respect to the output, the way I want. The output way what I want. Accordingly, I've given the prompt, right? And sometimes, many times, it will hallucinate. For example, I will show you. This one are, let's say, brothers. A lot of times it will hallucinate. This is an okay example. Mm, okay, anyway, we'll go to the hallucination examples after this. So I hope you have understood that once we give the information and ask a question, it will be able to answer the question. Okay. Now, based on that, we will understand this RAG approach. RAG stands for retrieval, augmentation, generation, guys. Okay, so the next 15 minutes is mostly completely about the architecture and explanation about RAG, retrieval, augmentation, generation, right? So this is a high level architecture. Let me, in the interest of time, I will quickly go to the more deeper level architecture. So in the initial part, we have this indexing phase where all of the files or all of the books about your company or about the university will be taken, and all of the text will be extracted, and it will be stored in a cloud storage, cloud or wherever. This is ADLS, is Azure Data Lake Storage. You can put it in AWS S3 buckets. Anything is fine, right? And then there will be a chunker that will go. It will actually divide the entire data into chunks, small chunks, small chunks. What are these chunks? So it is just a logical unit representation of text. So imagine you have a book. A book is made up of many pages, and pages are made up of paragraphs, and paragraphs are made up of sentences. Sentences are made up of words, right? But the first three sentences could represent one thing, talking about when was the company founded? When was the company founded? Who are the founders? Okay. And in the last paragraph, first two sentences could be representing one chunk, uh, talking about what was the motivation for them to start the company, or something like this, representing one logical unit, divided into chunks. Okay. And all of the chunks will be converted into an embedding. So all these are text data, right? Text data will be converted into vector representation, numerical representation, because models cannot understand text data, on a very deeper level, because models are nothing but, when you look at machine learning model, any model is, let's say a neural network model is like this. So here you have inputs, here you have weights, right? And here you have, so ultimately it is nothing but bunch of arithmetic operations. So you have 3, 2, 6, so you have 3 into 6 plus 7 into 8 plus 9 into 2, and then you will take tan h of that because there will be activation function, tan h of this. So it's all an arithmetic operation, right? Model internally is nothing but bunch of complicated arithmetic operations like this. And arithmetic operations make sense only on numbers. It arithmetic operation, what do you mean by 3 into, let's say the founder name is Rahul. 3 into Rahul, what does it mean? Doesn't make sense. So it's only numbers. So obviously that's why we will convert everything into numbers. Text will be converted into numbers. Images will be converted into numbers. So here the chunks, the entire data got converted into small chunks and that got converted into numbers like this, which will be saved in a vector DB, which will have the embedding and the corresponding chunk, like a key value pair. Key value pair, usually we have in data structure and document based databases, right? It's a vector based database. So once this is ready, this is where the magic happens. This is all indexing part. Sorry, this this is all the indexing part. Now comes the RAG part. So each and every word is important here, guys. RAG, RAG. Okay. First, user would enter a query. So he would say, what are the products of Seagate? This is a text. Now, the same model, what was used in LLM model, will be used to actually convert text into vector. Text into vector. Okay. The same model will be used over here. The user input will be taken and you will get a vector. User input will be taken and you will get a vector. And that vector, whatever this vector is, 30, 20, 60, that vector will be taken and a cosine similarity search will be undergone. Cosine similarity search will be undergone with all of the vectors. So let us say here I have 10,000 chunks. 10,000 chunks. Therefore, I'll have 10,000 vectors. One chunk, one vector. One chunk, one vector. So 10,000 vectors. So among all these 10,000 vectors, which are the top 5 similar vectors to this vector will be identified. That will be called as retrieval. Retrieval. You are retrieving the relevant chunks to answer your question. To answer your question. And I will tell why this is important. Okay. After that, the context, this is considered as context, all the top 5. The context will be combined with the query and with a prompt, let's say answer in one line, explain why the answer is derived, how the answer is derived, and so on. That will be taken and given to LLM. Given to LLM. And LLM will give the output. So first part is R. This combining everything, combining the top 5 chunks called as context and combining the query and combining the prompt is called as argumentation. Argumentation. Okay. And this part is called generation, which is done by LLM. Done by LLM. Now let's come back to the example. So now here, as I have shown you in the chat GPT, you see here, same example. Okay. Yeah, this example. So observe this. Did I have a query here? Yes, I have a query. Did I have a context? Yes, this everything is context. This everything is context. Right. And then can I give a prompt like answer in one line? I can tell. This is a extra prompt I'm giving. Prompt template, or you can call extra prompt I'm giving. Yes. So I have a query for a particular context and I'm asking to answer in one line, which is a prompt. So I am having these 3 things, right? So my LLM did not know anything about Sachin and Rahul, but I gave the context. My LLM, to my LLM, I'm asking a question to answer based on this context and answer within one line. So this is exactly what I am trying to do. So I am combining context and query and prompt in the augmentation part and then giving it to LLM like I have typed it and sent it to my chat GPT here, right? Nothing but give it to LLM. In the code, you will give it to an API call of LLM, right? Of the LLM. So that's exactly what is happening. And because of that, you would get the answer. Now, because of that, you will get the answer. Something like this. HD, USB, etc. are what is available in products of Seagate. Okay, now let me quickly go to the notes, guys. I have made this quick notes to make it understandable even much better. So I will just tell this again one more time. Consider you have Harry Potter book series. Around 9 Harry Potter books are there, right? 9 or 7, I don't know exactly. So all the books are taken and text is extracted from all of the books. All of the books, Harry Potter, Stone, Wizard, like this, many things are there, they are extracted. Okay. And this is the text corpus you're dealing with. Now for this text corpus, you will do chunking. So first this part, initial this part you will have here. And then one more part you will have here. One more part you will have here. Like this, there'll be many chunks. There'll be many chunks. Okay. And for each chunk, every chunk I'm passing it to embedding model. Embedding model. Okay, which is again an LLM, let's say ADA model or whatever it is. Okay. So these are converted into this embeddings. Converted to this embeddings. Okay, so now I have this and I will save everything in a vector DB. Embedding and its corresponding chunk. Embedding and its corresponding chunk. I'll save everything in vector DB. So now if I ask a question like this, first of all, I want you to answer. I ask a question, what kind of pet does Harry Potter own? So my question is to answer this question, what kind of pet does Harry Potter own? Do I have to read all, do you have to read all of the 7 books? Should I read all of the 7 books? Yes or no? Yes or no?
Sir, your writing is not visible, sir.
Can you see the notes?
Yes, sir, your PPT is visible, but whatever you are
No,
writing
no.
is not visible. Annotations are not visible.
No, not PPT. I am sharing some notes. 1 second.
Notes is visible, but writing is not visible.
Okay, okay. 1 second. Yeah, so you can see this, right? Harry Potter question that. Can you see? No? Yeah, can you confirm, guys? Anyone? So I'm showing this. I'm not sharing PPT here. 1 second.
Okay, okay, sir. Question not visible.
Question is visible, right?
Question not visible.
Not visible.
Yes, sir.
Okay, 1 second. Let me close this. I am sharing. Okay, so what? Let me do one thing. Just give me 1 minute. I will forward this and I can show it, guys. 1 second. Yeah. Where is this? Yeah, here it is. Yeah, so have a look at this. Now I think you should see the notes, right? Okay. So what I was saying is I have all of the documents of Harry Potter book series. 7 books are there and all the text has been extracted. And that entire text got converted into different chunks like this, small parts, chunks like this. Right? And each chunk can be of 512 words, 256 words, and then some common things will be there. This is a common. It is to find, it is to find. Common will be there, okay? Overlap. And after that, chunks will be converted into numbers or vector representation like this. So using an LLM called ADA or whatever it is, BART, whatever it is. And then finally, I will save everything in a vector DB. I'll have a embedding and okay, I think it is paused. 1 second. 1 second, guys. Yeah. Yeah. So all the data has been extracted and the data from the data chunks have been created like this. And each chunk got converted into vector like this. And everything will be stored in a vector DB. The vector and its corresponding chunk, vector and its corresponding chunk, right? Now the user will ask this question, what kind of pet does Harry Potter own? So already you guys have answered that only latest book is, you don't need to read everything. The point is you don't need to read everything to answer the question. If a human wants to answer the question, maybe he will just go to that particular book and page number 35, let's say, where somehow, it's talking about Harry Potter book. You'll search from page 30 to page 38. You will read all that pages and you will find, okay, he actually owns a owl called Hedwig. People who remember can actually correct me. I may be wrong here, but I'm just telling, Harry Potter owns an owl called a pet called Hedwig owl. So to answer this, just if I look at 5-6 pages, it's enough. Think of it like a dictionary. If I want to know the meaning of, let's say, melancholy, I don't need to go through entire dictionary. I will go to the place where dictionary starts with M and then MEL. Like that, I will go and then I will see what is the meaning of this word called melancholy, right? That's how we do. So in the same process, but here the things are not organized in like a dictionary. We know that. Information can be there anywhere. The information can be there anywhere. So what we will do is we will create embeddings like this. So for the question also embedding will be created like this. Look at the embedding. It looks 108, 99, 160, 206, 30 and so on like this. Usually 768 dimension will be there. 768 features will be there. 768 values will be there like this. Fine. This one I will take, which is the query embedding, and I will apply cosine with all of the embeddings of every chunk. Every chunk. How many I might have? I might have 10,000 chunks, let's say, from all of the Harry Potter books. Why am I doing it? I am doing it so that I will get the relevant chunk. The question has words like pet, Harry Potter, own, kind, etc. Right? Now let us see. See here, if you see Harry Potter enters train, notices doors and opens it to find. Is this a relevant chunk to answer this question? No. Here it's talking about train is entering, but my question is about what pet is owning. And this is also not relevant chunk. So what will happen is, if I take this vector and this vector cosine similarity, the similarity will be very low, like 0.003. Similarity will be very low. That's how the vector will be created. Vector will be created because each vector represents something about, whatever it is. Now you see Hermione, pet, cat left the room. So this 100, 160, 80, 108, 90, 120. So these are similar because there's a word called pet here and I'm asking about pet. So there is a similarity between this one and this one. So this one is little bit similar to this one. But the answer is somewhere over here. Harry was happy to see Hedwig, who is sick, right? And Harry looks take care of his pet very well, Hedwig, who is a baby all and is very mischievous. So is this a relevant chunk? Yes, it is. Because it's talking about the pet. This chunk is talking about the pet and it has the name of the pet and that it is sick and it is mischievous and everything. You see the value here, 110, 105, 108, 99, 160, 140. So they're similar. Therefore, what will happen is the cosine similarity between this chunk vector and this chunk vector will be 0.9, let us say, which is very high, Therefore, the model will get to know which chunks to look. So now I will fetch the top 5 chunks. Top 5 chunks I will fetch, which are this. Hedwig, Harry Potter loves to take care of his pet. Happy to see Hedwig sick. He's sick. Hedwig ate his supper. Hermione, pet, cat left. Like this, top 5 chunks are there. Fine. Now this top 5 chunks, I will take it and put it together as a context. This is retrieval part done. Retrieving the context, retrieving the information where the answer for the question might be there. Retrieving the information or the chunks or the context where the answer for the question might be there is done. It is done using vector search, similarity search. We created vectors so that we can search easily like that. It's a simple mathematical numerical calculation. So next is argumentation. Argumentation, what will happen? Entire context, 5 chunks will be taken, query will be taken, and answer in one line prompt will be taken. Argumentation is done. Now, what is the next step? Can you guys tell what is the next step? Yeah, semantic words are also considered while building the vector, embedding vector. They are taken into consideration. Otherwise, it will not perform well. They will be taken. So retrieval is done, argumentation is done. I got the
relevant chunks where the answer may be there. And I'm also added the question. I've also tell in one line. Now, yes, I will ask the LLM. This will be sent to LLM. Okay, which is GPT 3.5. I am asking it to look at this information. Based on the information, can you answer this question? If possible, answer in one line. It will tell owl, comma, Hedwig. That's what it will tell. It will be able to tell. Now, did my GPT 3.5 model, did it actually learn the Harry Potter books? Did it learn the Harry Potter books? Yes or no? It has not learned the Harry Potter books, obviously, because I didn't do any fine tuning. What I did was, for any question, where could be the potential answer? For where could be the potential sentences or context? I just retrieved that. I just showed it to LLM. Hey, LLM, you need not learn everything from a Harry Potter book. This is where the information for this question might be there. So take this information and take this question, and based on this, can you tell me the answer? Sometimes it cannot tell answer. Sometimes it cannot tell because I may ask irrelevant question. I have shown you, right? I asked, where is Rahul working? Obviously, I have not given that information. So ChatGPT failed to answer that question. So that's what it is. That can happen. So if you see this image, this is exactly what that you see. Stop screen share. Let me share it again. Just a second. Yeah, here it is. You see this particular image. This is exactly what RAG is. RAG is like a AI chatbot scanning through which pages the information is available, and then based on that answer, right? So something like that, that's why I put this so that you can quickly recall and remember. Yeah, so these are the important concept about RAG, guys, and there are many issues with RAG: hallucination, latency, these are some technical metrics, and I have written many other challenges and how to improve accuracy overall. So finally, what happens is, initially, this is what the auditor was burdening with all the files to actually go through. But with the help of a RAG-based private chatbot, he would feel much relieved because he don't have to go through all the pages. He can ask the question. He can just upload the pages and he will ask the question from RAG-based ChatGPT, right? And there are many things. But so before we get into questions, I want to quickly demonstrate the code, guys. So I will be taking this page from the internet, right, as a part of my document. I will take this page, all the text data I will extract. All of the text data I will extract. So I am not using any paid version of API over here because I want to deal with the free version of LLM from Hugging Faces. Because if you guys want to try, I will share this code file. If you guys want to try, anybody can try it because it's a free LLM, open source LLM. If you go for GPT-4, GPT 3.5, these are not open source, these are closed source. You have to pay $20 per month to get the API key, right? But not everybody might have, and obviously I can't expose my API key, and nobody should. So I'm using a free LLM so that you don't have to worry about API key and paying $20. So I have installed Hugging Face and I've installed LangChain. Okay. And then from Hugging Face, I'm actually downloading this model called T5, which is again an LLM, but not as huge of a size compared to a GPT. And therefore, I can actually run it in my Google Colab with just 16 GB RAM. 16 GB RAM. Otherwise, it won't be enough because I'm downloading it. Now I'll have this. Now let us see. So this is all the process. You'll split it. We'll split the PDF into chunks, and you will store it in VectorDB, and then you will have retrieval, and then all of these things you just explained. Now I'm reading my text from the website using a scraper called web-based loader, and then I will split it. I have to split the entire text into chunks, which will be done by this one. And this is from LangChain package, or LangChain framework. Inside LangChain, you have text splitter sub-library. In that, you have recursive character text splitter class. class and method. You have method called recursive character text splitter. What it will do is you can define your chunk size and chunk overlap. So if there are, let's say 10,000, let's say 5,000 words, 5,000 words, I'm telling to create chunks, right? Text split it and make chunks. Each chunk 500. So total words are 5,000 divided by 500. Each chunk size, totally I'll get 10 chunks. 1, 2, 3, 4, like that, 10 chunks I'll get. But I am not dealing with 5,000 words over here. I don't know how many are there, but I'm just telling as an example. Okay, an overlap you can have between chunks, that is good. Usually we'll have overlap. And then, yeah, now I will download my vector database because I need to, first of all, create the embeddings and then save that embeddings and the chunks both together in the vector database. FAISS stands for Facebook AI System Search, Facebook AI Search, right? Search service, right? So this one, and then I will have Hugging Face embedding generation, embedding. So I will be taking my chunks and then I will create embeddings from this, from a model called Sentence Transformer, which is of base version 2. Right, and I'm asking it to use CPU. You can use GPU because one GPU is free in Google Colab, so you can use GPU also. It's quite small, so I'm taking only CPU. So it's taking time to create the embeddings. Once it is done, I will save it in my document. Now I can see a vector search. I can see the vector search. Okay, now let's see how we can do question and answer. So what we did so far is indexing. This is called indexing. This entire step is called indexing. Indexing means simply saving your data in a database in a particular indexed format so that search will be efficient. So what data did I save? This URL, whatever your data is there, I have taken all the text data and I divided it into chunks, and each chunk I created an embedding and saved it in FAISS vector DB. Now starts the question and answer. Question and answer. I will ask a question, what are transformers? Because this website, this blog is about transformers. Is explaining about transformers. So I'll ask a simple question. What is it? What are transformers? So the question will be saved in this. And then all I have to do is vector store dot similarity underscore search question. Vector underscore store. What is vector underscore store? This is vector store. Vector store. Vector store is FISS dot documents, where you have all of the embeddings and the corresponding chunks. So similarity search, which means cosine search, will undergo. And I have observed, I have not created embedding for this. Automatically, this will do it for you. Okay, it'll do it for you. So after that is done, when I do the similarity search, you will get the top chunks. This is the first chunk matching. This is the second chunk matching. This is the third chunk matching. Okay, you got the top chunks, right? Now to make it even more streamlined, people use this chain type where actually you can have the RAG, all the three parts of the pipeline, all the three stages of the pipeline integrated very well, right? Integrated very well. So now I'll take this, what are transformers, and then what is attention mechanism, next question, and I can also have conversation summary. Yeah. So now if I have it in a chat model, so I have chat, I'm asking explain self-attention. So it is giving me the answer. First, it is entering LLM chain and then finish the chain. And then finally, the answer is, yeah, here the answer is. Whatever is there in this is the answer. Using the following piece of context, the answer to the question. And if you don't, this is what I've given in the prompt. Self-attention is at high level. Don't be fooled. Self-attention, like it's a concept everywhere, should be familiar with. I had personally never come across attention is all you need people. Let us discuss how it works. It's pretty much, yeah, this is all the answer you're getting, right? So it's like you have your chatbot developed, which is able to answer any question. All you have to do is have the chat and then give the question, and you will get the response. Provided that response is available in this text, in this URL, in this web page. Okay, so that is the main idea. If anything I ask beyond, then it will not give me the answer. So let's say if I ask explain what is agent in Gen AI. So it is giving some answer. I think there is some answer available in that. So it is giving some answer, right? So this is the basic code demonstration. It is very simple, and it has been, most of the part has been implemented using LangChain. If you want to try Gemini, then I would say that Gemini has a free version also. Gemini AI Studio, Gemini free API is there. But I would not suggest. The reason I will not suggest is because there is one catch. 1 second, guys. Let me show that. Gemini AI Studio API. So Gemini is giving free API for everyone. But the problem is it will use your data for the part of the training. So if you give any of your personal data, it will be used. Google will learn it, right? But if you take a paid version, then Google will not learn it, right? That's what they promise. But anyway, be cautious with all of these. Always go for open source free LLMs which you can download from Hugging Face. Okay, so now this is all what I wanted to. Yeah, now let me come back to these slides. Yes. Okay, so I said I would have around 15 minutes for questions, but I was able to finish just 5 minutes before, guys. But I hope we can stretch a little bit. I will be very happy if you can come up with any questions. It will be a good discussion. And I want you to tell me, when would RAG fail? I have given some important points where RAG would fail, because it's not a perfect system, right? Can you think of some places where RAG will fail? That is, you will not get the answer properly for questions, right? You will not get answers properly. Fine tuning will work, but RAG will not work in some cases. What are those? Can you think about something? If you can you tell me? Open source LLMs from Hugging Face, you can download any. I would say Hugging Face, you download ADA for embedding. Okay. And T5 for LLM generation of response. Yeah, I have typed it from Hugging Face. Okay, and as you can see, these images are also AI generated, which are from straight away from prompt engineering. All I just did was put my image and then just gave a prompt of how this thing should be. Okay. So all right, guys, any comments, any points, any ideas you want to share, you want to discuss?
Good morning, sir. This is Lakshmikant Reddy representing Anwar University. I'm an assistant professor in Department of AI. Sir, there is a lot of transformers in different subsets of AI, like in machine learning, its usage is something, it's in
Yeah.
deep learning, its usage is some other purpose with respect to neural networks. In the same
Yes.
way, is there any role of transformers in RNG also? Because in generative AI, also transformers are playing some role. So in the same, is there any transformer in RNG also, retrieval augmented generation?
No. Transformers is not used here
No.
because we are doing is vector search. When the embedding is created for the text, so ADA model I'm using to create embedding or vector of the text, right? That will be using transformers internally.
Okay.
Right, so it will be using transformers. So we are not explicitly, implicitly actually typing the transformers code. All we are trying to write the code in RAG is the cosine similarity and the chunk size, overlap size, number of chunks. There are some hyperparameters which we have to define all these, right? Only this. And the transformers part will be taken care by the embedding model on its own. But it is part of RAG only for the numerical representation of the chunks.
What exactly is RAG, sir? Like, in the generative AI, what exactly? What is the main? There might be some usage of
Chatbots answering questions. So let's say you will give your resume to me. Your resume is made of 4 pages. Okay, so I can just give it that resume to my RAG system, and I'll ask where did Mr. Lakshmikant graduate? What is his research? It will tell me the answer immediately. I don't have to go through one by one, right?
Okay.
And just actually one more. I'll give you one more example. It's a good question,
Yeah.
for it will be useful for everyone. So, 1 second. Here, as you have seen, 1 second, guys. ChatGPT, I have given some context here, right? Context I've given.
Yeah.
Now, if I give everything, all of this much as context, it will not accept. It will tell I am a limit exceed. So answer, where is AI used in healthcare? Okay, I ask, it is still giving me, but what happens is, if I have too much text, let us say I give 20 pages, 20 pages data I have copy pasted. Okay, 20 pages data I have copy pasted here, and I'm asking a question. ChatGPT will throw error saying that I have a token limit size of 28K or 32K or 48K, whatever. So there is a token limit size. Okay, and right now, Gemini actually has 1 million tokens limit, but nobody will use it. 1 million tokens, nobody will use it. The reason is, to answer one question, it has to go through 1 million words. How is it relevant? We just learned that it's not necessary to go through all of the words, everything. We just have to go through important one. Right now, token size is increased, but that's also a problem. And every token will be costed. For every token, you have to pay $0.003 or whatever. So if you use more tokens, you will be costing more. So that's where industry wants optimal solutions like RAG, and also combination of RAG and fine tuning.
Okay, sir. Questions to the center?
Sorry, your voice was breaking completely.
Yeah.
Actually, I'm not able to hear anything. If anyone else was able to hear, can you tell me, guys? What's the question? Would you place where users on Gemini is again same LLM like all of these, GPT-4 and everything, but Gemini has many versions. Gemini Pro Ultra, Gemini Nano, something is there. 3 versions are there. Gemini is multi-model, which means you can give input combination of text and image. Right, yeah. ChatGPT uses GPT-4, which is not multimodal, which is of only one kind of an input it can understand. You have to give image separately, text separately, and then integrate it later. When you go with Gemini, one input can consist of image also, text also, video also it can consist. You can give everything combined as an image. RAG are used for textual data only. Any data, image, video? No, only on text data. Images also you can use. Videos nobody has done it yet, but people can do it. Everything is, just think about it. Everything you just have to convert into numerical representation and do the cosine similarity. Can you convert image to numbers? Yes. Can you convert videos to numbers? Yes. Text to numbers? Yes. Signal processing, you will have values, signals you will have. That also you can convert numbers. Anything. So you can do it everywhere.
Sir, there was one question from Ganga saying that can we use ROG for text similarity based applications where we need to compare two given text and give the result?
Compare with what?
Can we use ROG for text similarity based applications where we need to compare two given texts and give the result?
Yeah, you can. That can be done. Yes.
Any more question, participants?
Yeah, that can be done. You will not have generation part maybe then. You don't want to use LLM, I think. You just want to give similar results like you're saying. So accordingly, you can change the architecture as per your need and you can implement it.
Okay, sir. Is there any more questions from participants? Sir, the significance of cosine similarity in RAG? This was asked by Srinivas. What is the significance cosine similarity in RAG?
Yeah, significance is to get the relevant chunks. So if you take the word called dog, and you have word called ice cream, and you have word called cat, and you have another word called chocolate. So now if you want to know which words are similar, dog will have a numerical representation, let's say 120. Cat will have 110. So when you find the difference between these both 120 minus 110, it is 10, which is small number, which means dog and cat are similar, obviously, because they have animal background. And ice cream and dog, ice cream is 300, dog is 120. Difference between them is 180. Difference is similarity is very big number. If you take the distance is 180, distance is very big number, which means they are not similar. If you go for only similarity, you will have to look for the similarity score, which means let's say dog is 100 and cat is 110. So similarity, if you see, then the similarity score will be, let's say, 0.9. 0.9. And similarity between dog and ice cream. Dog is 110, ice cream is 300. The similarity is 0.1. So it is to identify for this question which are similar sentences in the entire book. And in that sentence, there may be the answer. Sentence or chunks. I asked the question about what is the Harry Potter pet name. So wherever there are sentences or chunks which have the pet words such as pet and Harry Potter and whatever, those will be more similar. And wherever there are chunks which has words like games, sausage stone, war, magic, then they are not that similar to the question. So idea is to identify the similar ones. And 120, 300, that's the numbers I told you. Here we are taking vectors. Vectors. Every word will be represented a vector. Every chunk will be represented as a vector.
Sir, there is one question from Asma Tehsin asking for any tool to summarize 60 papers in single document at same time.
Yeah, you can use Grok, which is open source. Yes, it is open source.
Okay. So there is another question from Associate Professor of Ahmedabad University, Dr. M. Trupti, asking you, other than the vector search algorithms, are there any algorithms available to enhance the efficiency of the model?
Yes, there are. So you have Mahana-Lopez distance, right, which will look at similarity in terms of certain dimensions, certain particular dimensions. You don't want to look at similarity in all dimensions, right? If you have a vector with 768 dimensions, not necessarily the words or chunks should be matching in a majority of the dimensions. Some are enough. What are those some? If you want to give more priority, then you have Mahana-Lopez distance. But usually people are not using that. People are using cosine similarity in the industry. Followed by that, they will use many other alternatives for retrieval, like corrective retrieval, pre-retrieval process, post-retrieval process to actually overcome the downsides with RAG. Okay, and one more thing is research paper. If you want to get summary, you can use the code that I have shown you. In the code that I showed you, I took the URL of this one, the blog. You can give URL of the research paper, and the same thing will be retrieved in your code. The text will be retrieved, and you can ask questions about the research paper. You can chat with it. You can chat with the research paper, something like that. Okay. Yeah, but don't expect it to be performing significantly high because it's a very base model.
Thank you, sir. Thank you for your, sir. There is another question from Monica.
Yeah, sure.
Can you share the code, sir?
Sure, definitely. I will share everything. I'll email to the appropriate members from Anurag University. And also, last, I would like to thank everyone, guys, for this opportunity. It's really a good, interesting session. I hope we had. I hope it was of some value. And thanks to all the coordinators, Madhu specifically, she has, Dr. Madhavi, her name, she has been explaining about the process and all these deadlines and time. I think just thanks a lot for keeping the coordination smooth. It's really helpful. I just request everyone, if you can actually turn on your video, if we can take a quick screenshot, I'll feel very happy towards the end of the day. If you can do that, it will be very helpful, guys. I request everybody to come on screen just a few seconds and let us say something and let's take some screenshot. Let's see if I can do it.
Thank you, sir. Monica, sir, for your excellent session. We have and we associated with you since you are in our and you visited campus from representing labs earlier for previous sessions also. Thank you
Yeah.
for being on the board and having excellent sessions, sir. Thank you.
Okay. Okay. Thank you, guys. Thank you, everyone. Yeah. Thank you, guys. Bye.
Bye.
Thank you, guys. Bye.